Dear students, under the topic double integrals, here we have problem 2. Already we have solved problem 1 in our previous video lecture. So kindly go through that lecture first and then follow this lecture. Now here the question is evaluate the double integral of x square plus y square dx dy over the region for which x and y are each x greater than or equal to 0, y greater than or equal to 0 and x plus y is lesser than or equal to 1. So first of all, as the first step, we have to sketch the region given. So in order to sketch the region, we observe that both the values of x and y are greater than or equal to 0, which means that we are concerned only about the positive quadrant. And let us draw the line x plus y lesser than or equal to 1 in the positive quadrant. That is, we are going to now draw the lines x equal to 0, y equal to 0, which will give us the x-axis and the y-axis. And after that, let us draw the line x plus y equal to 1 in the first quadrant. And the region that we are concerned will be the region below the line x plus y equal to 1, because it is lesser than or equal to 1 over here. So first let us draw these three lines. So first we have drawn the x-axis and the y-axis, and the equation along the x-axis is y is equal to 0. So this is the x-axis, and the equation along the y-axis, so since this is the y-axis, the equation along this axis is x is equal to 0, and this is the origin 0 comma 0. Now we have to draw the line x plus y equal to 1. We know that this line is it will be in this way, but how did we get that? Let me just show you. Now we are going to draw the line x plus y equal to 0. So in this, if you put x is equal to 0, what will be the value of y? Y will be equal to 1. So this is one of the coordinate that satisfies this line. Another coordinate can be if you put y is equal to 0. That is the point where it touches the x-axis and the y-axis is what we are going to find. Now in order to find the point where this line touches the y-axis, we have to put x equal to 0 and y equal to, if we have to put x equal to 0, and thereby we have got it is 0 comma 1, and the point where it touches the x-axis is y is equal to 0. If you put y as 0, we get the value of x to be equal to 1. Now we can plot these points. For example, here it's 0 starts, and you can take that is 1 comma 0 over here, and 0 comma 1 somewhere over here, that is x-axis and y-axis. I'm not drawing it geometrically, so the measurements may be wrong, but this is how the line will be. So now what we have to do, we have to join these 2 points. So after plotting these 2 points that we have obtained, we have to join these 2 points in order to get the line x plus y equal to 1. So let us join that now. So the region under consideration is below this line, and the region bounded by the lines x equal to 0 and y equal to 0. Let me just shade the region and show you. So this is the region that in which we have to evaluate the given double integral. Now in order to do that, we have to find the limits for x and the limits for y, for which we have to draw a strip vertically or horizontally. I am going to draw it vertically. You can choose it to draw vertically or horizontally as well. It's up to us. Now I am going to draw a strip vertically, which is going to be parallel to y-axis. So this is a moving strip, and how it moves? It moves along the x-axis, that is like this. So this strip changes its length as it moves along the x-axis, that is, you could see that the strip will move in this way. So as it moves along the x-axis, when it moves, it will be covering the complete region that we need. So this is the required strip, and it moves along the x-axis, using which we can find the limits for x and y. The limit of x will be the movement of the strip, that is from where to where the strip moves will give us the limit for x, and the limit for y will be the length of the strip. So let us see how to find that now. Now the limits for x will be the movement of the strip, that is the strip moves like this. The strip starts to move from 0. So the limit for x will start from 0 to x is equal to where it ends. The strip keeps on moving like this. It moves and ends at this point. So it will end at this point where the value of x is what? X is equal to 1. So for x equal, it starts from x equal to 0 and it moves till x is equal to 1. So this is the limit for x. Now the limit for y will be the length of this strip. Where it starts in the line y equal to 0. So at this point the value of y is equal to 0. So it starts from y equal to 0 to, now it ends at where? At this point, which is a point on the line x plus y is equal to 1. So what will be the value of y from this? Y will be equal to 1 minus x. So this will give us the ending limit of y, that is the length of the strip, which is y is equal to 1 minus x. So this is how we have to find. And as the value of x keeps on changing in this, that is the strip is moving. So as it moves, the points also changes. So according to the value of x, the value of y will also change. That is how it is. So it is on this line, it keeps on changing. So anyway, the general limit is from 0 to 1 minus x. So we have found the limits for x and the limits for y. Now we have to integrate. Now since the limits for x is independent of any variable, this will be the outer limit, and this is dependent on the variable x, so it will be the inner limit. So the outer limit is for x and the inner limit is for y. So now let us write the given integral with the limits, that is double integral x square plus y square dx dy. So when we write with the limits, what do we get? It will be, as I told you, outer limit is x is equal to 0 to 1 and inner limit is y is equal to 0 to 1 minus x. And what is the function that we have to integrate? It is x square plus y square. And since the inner limit is with respect to y, first we should integrate with respect to y and then we have to integrate with respect to x. So it will be dy dx. So that's equal to integral 0 to 1. Now after integration with respect to y, first we have to integrate with respect to y. What we will be getting? X square will be treated as constant. So integration for x square dy will be x square y. Since the integration of dy is y, plus y square dy. What is the integration? It will be y cube by 3. And this is between the limits 0 to 1 minus x. And we have to write this dx over here. Now we shall substitute the upper limit and the lower limit for the variable y, since we integrated first with respect to y. So when we substitute the upper limit, what do we get? This will be equal to integral 0 to 1. Upper limit is 1 minus x. So here we have to put 1 minus x. So we will get x square multiplied with 1 minus x plus y cube. So 1 minus x the whole cube divided by 3 dx. Now we shall simplify this by multiplying this x square within the bracket of this term. So after multiplying we get, this is what we get. Now we shall integrate this with respect to x. So what is the integration of x square? It will be x power 3 by 3 minus integration of x cube will be x power 4 by 4 plus what is the integration of 1 minus x the whole power 3? It will be 1 minus x power 4 divided by, already we have a 3 over here, multiplied with 4, and we see that we have minus x1 over here. So we have to multiply, divided by a minus 1 also. So between the limits 0 to 1. So simplifying this further, on application of the upper limit, if you put x cube as 1, you will be getting 1 by 3 minus x power 4 as 1. If you put, you will be getting 1 by 4. And here when you put the upper limit, it becomes 0 because 1 minus 1 will be 0. Then we have to substitute the lower limit. So minus the lower limit. So here if you put 0, this term will also become 0. Here also it will become 0. So minus, here this term when you put x as 0, you will be having 1 power 4 divided by, and we have this minus sign. So it gets multiplied with this minus. So minus into minus will become plus. So it will be 1 by 4, 3 times is 12. So kindly apply these limits very carefully. So when you apply the upper limit, these two terms we get here, and this becomes 0. When you apply the lower limit, these two terms become 0 and this term comes here, and upper limit minus the lower limit. So minus into minus will become plus, and this comes as it is. Now we can take the LCM over here. So the LCM will be 12. So this will be 3 multiplied with 4. So 4 minus 4 multiplied with 3. So 3, and then this multiplied with 1. So it becomes plus 1 over here. So the answer will be 4 minus 3 plus 1 is 2. So that will be equal to 2 by 12, which is equal to 1 by 6. So this is the required answer for the given integral. So hence we have evaluated the given integral within the region that has been given. So I hope you would have understood this problem. So in our next video we will do problem 3 under the topic evaluation of double integrals over the given region. Kindly follow the next video lecture. Thank you.